This is the last section of Chapter 8, discussing a z-test for a proportion. Back in 8.2 and 8.3, we were looking at a z or t-test for a mean. Here we're looking at proportions, which is what a lot of you will be using for your research report to finish up with the inferential stats section. So if you recall, a proportion is the same as a percentage of the population. And think back to the end of Chapter 7, with the confidence interval of a proportion, we no longer use the symbol mu that represented the population mean. Here we have a population proportion, so we're going to use a variable p. So here are two examples of hypothesis statements. So if somebody thought 59% of consumers purchase gifts for their fathers, they would be writing out a hypothesis of the null hypothesis would be that p, again, not mu, but p, would equal 0.59. Maybe the alternative is saying that p is just not equal to 0.59. As we'll go through examples, we would also have to identify the claim. Another similar statement here is that 85% of people over 21 said they have entered a sweepstakes. So if your hypothesis statement is worded like the first two here, you would be using the null and alternative hypothesis as I have written out. Most of you did say the majority, so if you said more than or less than, you would use an inequality symbol here. So again, for more than 50% prefer whatever choices you were giving them. The null hypothesis again would be that p is equal to 0.5, but the alternative, which in this case, with this example here, this would be the claim, it would be that p would be greater than 0.5. And again, we would indicate that that's the claim. All right, so again, with looking at proportions, everything sort of boils down to two outcomes, which means that this is a binomial experiment, looking at the outcomes as being, yes, a success, meaning that's what the criteria you're looking for, or a failure, which is no, it isn't. Remember, the probability of success does not change from trial to trial. So we have a new formula to find our test value. Remember, this is a z-test for a proportion, so we're looking at the standard normal distribution, not the t-distribution. So in this case, instead of x bar minus mu, we're looking at p hat minus p. This is how we calculate our test value. So it's p hat minus p divided by the square root of the quantity of p times q divided by n. Remember, n's our sample size. Q is the complement of p. It's just 1 minus p. And sometimes we have to calculate p hat. Remember, p hat is just the quotient of the number of data values that meet your criteria divided by the sample size. Here we always have assumptions. The first one we keep seeing time and time again is that the sample should be a random sample. In this case, because we're dealing with proportions, the conditions for a binomial experiment must be satisfied. The third one, I don't focus too much on. We really just look at the first two that meets our needs. But all this is saying is that if we multiplied n times p and n times q, we would get a value greater than or equal to 5. If you explore more detailed or higher level stats courses, they will go over that. All right, so I have just 4 examples I want to talk about. We're going to switch back and forth between a traditional method and then the p-value method. So we're still following the same 5 steps. We're just using p instead of mu and the new formula for the test value. All right, so go ahead and pause the video and just read this to yourself and then continue. We are going to use a traditional test on this one. So notice the very first sentence, a dietitian claims that 60% of people are trying to avoid trans fats in their diets. She randomly selected 200 people, so that's our sample size, and found that of those 200, 128 stated that they were trying to avoid trans fats in their diets. We do have an alpha level given to us here, 5%. Is there enough evidence? Should be evidence here to reject the dietitian's claim. And that word reject is a big key word there. Reject, remember, goes with the null hypothesis. If it's said to support, that would give us an idea that the alternative hypothesis is our claim. So step 1 is that the null hypothesis, again, is p would be equal to the 60%. That is our claim, or the dietitian's claim. The alternative hypothesis is that p is not equal to 0.6. So we have a two-tailed test here. I'm going to just make a little sketch. It's going to help us because next we have to find our critical values. So we have our tails shaded in. We have to find the 2 critical values. So if alpha is 0.5%, that means alpha over 2 is what I'm going to write in here. And this is what we're going to type into our calculator. So if you go to the area, so in this case we're looking at menu 553 on our calculator. And we want to type in a 0.025. So we're looking at a critical value for step 2 should equal plus or minus. Now if you're typing in the 0.025 as the area, it's only giving you a negative 1.96, but we have it at both. So we have a negative 1.96 to the left and a positive 1.96 to the right. So those are our critical values. Step 3 is we want to find our test value. And please always, even if you don't number them, please show your steps neat and organized like this, especially on your research report. This part, along with the confidence interval, is going to go in the appendix, so please make sure that you're writing this out neat enough. Make it easy for me to follow. So our test value, which is z, that's equal, this is a formula that I just had on the previous page, p hat minus p over the square root of p times q divided by n. So in this case, p hat is going to equal the 128 over 200. No need to round, this does stop right at the hundreds place, so it's 0.64. So we're getting a 0.64 minus 0.6 or 0.60 divided by, again, p is 0.6, that makes q 0.4, and our sample size is 200. So pause the video, go ahead and calculate this, and you should be getting positive 1.15. So if I go to plot this on the sketch up here, 1.15 is showing up in the non-critical region. So our decision is that we do not reject the null hypothesis. And then to summarize the results here, we would say there is not enough evidence to reject the dietitian's claim. Now again, in your research report, in this step you would want to restate what that claim is, but for right now we identify the claim in step 1, which is very important, because if you're saying it in step 5 but you have no indication what the claim is, you would want to definitely go back to step 1, make sure you have that claim identified. Alright, let's take a look at example 2. We're going to use the p-value method on this, so go ahead and pause the video again, read it to yourself, and determine what the null and alternative hypotheses are. Alright, so in this case it says in 2000, 60% of the respondents of a survey stated that it was very easy to get time off for these circumstances. A researcher wishes to see if the percentage who said it was very easy to get this time off has changed. So originally it was found to be 60%, but they want to know if it has changed, so it's something other than the 60%. So it's just a coincidence that we're using the 60% again in this problem, but this time the claim is that it's something other than 60%, so it's the alternative hypothesis. This is still a two-tailed test, but we're going to use the p-value method here. So we're looking at area off to the right and then to the left here. So this means in step 2, we don't find the critical value, we find the test value. Again, which is z. That's going to equal p hat. In this case, the p hat was already given to us as a percentage. That's the sample proportion here. So we're looking at 0.53 minus p, which is the 0.6 or 0.60, divided by the square root of 0.6. That's p. 0.4 is q again. And our sample size this time is 100. So go ahead and pause this to calculate this, but you should be getting a negative 1.43. Alright, so that's our test value. Now remember, this is what we're going to use for to find our alpha values, or actually alpha over 2. Not necessarily alpha over 2, but to help us with our p-value here. So our alpha is the 0.01, which is what we're going to compare the p-value to. So for step 3, we want to find the p-value. So when you go to menu 552, all right, I'm going to use the lower, obviously we're looking at a test value of negative 1.43, so that means that is going to be our upper bound. So when you go to menu 552, you're going to use the negative infinity or whatever's already there by default as the lower bound, and then you're going to type in the negative 1.43 as the upper bound. So this gives us area on either tail as being a 0.07, leave it at 6. So then we need to double this. So the p-value then is going to be 2 times the 0.076. So our p-value is about 0.152. So to get our decision, we're going to compare our p-value to alpha. So we're looking at 0.152 compared to alpha is 0.01, and clearly the p-value is greater than alpha, so we do not reject the null hypothesis. Which tells us, so again, our claim is that it's something else, so we would say if we don't reject the null hypothesis, we cannot support the claim, so we would just say there is not enough evidence to support the claim. All right, so again, if anything, we're getting more practice. We just have a slightly different formula we're using here, but everything else, as you have seen, has been the same as what we've been looking at in the first two, or sections 8.2 and 8.3. So let's practice 2 more. Go ahead and pause the video to read this one as well. All right, so for this, we're going to use the traditional method. We have a statistician read that at least 77% of the population opposed replacing $1 bills with $1 coins. To see if this claim is valid, the statistician selected a sample of 80 people, found that 55 were opposed to this. At the alpha equals 1%, test the claim that at least, so at least in this case, we're going to be looking at something that kind of showed up in a previous worksheet. I think it was a worksheet to 8.3 we're looking at here when we go to state step 1. So we're going to have that P is equal to 0.77. I think it was like the heights of buildings, it was at least 700 feet. So in this case, it is the claim because at least means equal to or greater than. So we can't have a greater than or equal to as one symbol. Remember, the only hypothesis that could be equal to is going to be the null hypothesis. That means the alternative hypothesis means it's going to be less than the 0.77. So again, I know this is the wording here, but test the claim that at least 77%. So we're looking at 77% exactly or something greater than. So we could settle for just 77% exactly. And then the alternative would just be that it is less than the 0.77. All right, so step 2 is to find the critical value. So this is a one-tailed test, a left-tailed test, so just to make a sketch here. So we're just looking at this part right here. Again, we have alpha at 1%. So if you go to menu 553, we're typing in just the 1% that's here. So our critical value is going to be a negative 2.33. And then we're going to find the test value. So we're looking at this right here as a negative 2.33 for our critical value. Step 3 is that we'll find our test value, which is Z. So P hat, we have to calculate. P hat is going to be of 80 people, 55 were opposed, so 55 out of 80. Again, we'll just round this to the nearest tenth, so we're going to get a 0.69. So then this becomes a 0.69 minus 0.77. over the square root of 0.77 times 0.23 divided by 80. And go ahead and pause this to calculate it, but you should be getting a negative 1.70 here. So when we're looking at that, it is coming up to the right of it. So we have a negative 1.70 here, which tells us we do not reject the null hypothesis. All right, so since the null hypothesis was our claim, we would say there is not enough evidence to reject the claim. And again, the claim being that at least 77% of the population are opposed to the change, which means hitting that 0.77 or something greater than it. So again, we can just settle for being exactly at the 0.77. All right, and then we'll go ahead and try one more. So what I'd like for you guys to do is to pause the video, try example 4 using the p-value method in its entirety, and then continue with the video to watch to see what you're coming up with. All right, so here the null hypothesis is going to be that p is equal to 25%. The alternative is that p is going to be greater than 25%. Because again, it's just saying that an attorney claims that more than 25%, so that's what we're looking at here, which makes this alternative hypothesis the claim. So step 2, we're using the p-value method, so we want to find our test value next. This would become a right-tailed test, so we don't have to double the area that we would try to find here for step 3. So here we have, again, p hat would be 63 out of 200. And again, depending on how you rounded this, in this case, we could take it to just 0.32, but it turns out to just be a 0.315. So if it does end at the third decimal place, that's still fine too. So in this case, I'm going to put in a 0.315 minus 0.25 divided by the square root of 0.25 times 0.75 over 200. All right, so go ahead and pause the video and you can calculate this if you're just following along. But if you're checking this, maybe you got the same thing here, hopefully. 2.12 is what we can round to. So now we want to find our p-value. So we would want to use the 2.12 because it's a right-tailed test. That's our lower bound. So when you go into menu 552, type in the 2.12 as a lower bound, positive infinity or the 9E999 for the upper bound. And our p-value is equal to the area that we're getting, and you should be getting a 0.0170. All right, so we'll compare this to our alpha value. So 0.0170, and then our alpha is 0.05. So our p-value is less than alpha in this case, which means we do end up rejecting the null hypothesis. So that our summary of the results here is that there is enough evidence to support the claim. And again, the claim being that more than 25% of all lawyers advertise. So always when you're writing that step 5, go back and read the problem so you can remind yourself what that claim was and what we were testing here. All right, so this wraps up Chapter 8. I am going to give you guys Worksheet 8.4. However, I'm not going to give you a Chapter 8 test because I'll see if you guys understand everything you're doing as a good way to check your progress in the research report. Plus, the final exam is going to be here before we know it. So just to give you a layout of what the rest of this week will look like, I'm going to assign worksheet 8.4, and I'll have those answers posted over the next day or two. I'm also going to post the solutions to the final exam review, chapters 1 and 2, and then give you chapters 3 and 4 for the final exam review. After this, then, probably by the end of the week, I will have directions up for what I'm going to be looking for you guys to finish your research report. The final exam will be given during the week of May 13th, May 11th, I think is that Monday. I have to get, everything has to be done by the 15th. I think grades are due the following week. So we have 4 more sections, 3 or 4 more sections to get through. I'm not going to give any kind of chapter test over it. It will be tested in the final exam. Maybe some graded problems here and there just to test, just to check your progress over that. So I will have everything in great detail posted this week as far as what your assignments are as well as the solutions. But as always, guys, please take care and let me know if you have any questions.